Morning, everybody. We're going to continue in chapter 7 of that orange book. So, last class we talked about direct variation, and this class we are going to be talking about inverse variation. So, I wanted to start this concept of inverse variation by starting with a concept that you all be very familiar with, which is driving and speed to get to places. So if you're driving 200 kilometers to get from Vilnius to Minsk, if you're traveling at an average speed of 50 kilometers an hour, you can probably figure that out rather quickly. That trip is going to take 4 hours. Now, let's say you want to speed it up. You want to go to 100 kilometers an hour. That trip is going to take half as long. So this right here is a perfect example of inverse variation, where you see how the distance here doubled and the amount of time halved. That is a textbook case of inverse variation. So in other words, when one variable got multiplied by 2, the other does the inverse. So the other one got divided by 2. So as with direct variation, with inverse variation, we have what's called an inverse proportion. And so an inverse, for things to be inversely proportional, means as one is being multiplied by a factor, another one is going to be divided by the same factor. Now, there's a couple of ways here to denote inversely proportional. So then you can see this equation right here where it's y equals k over x. And if you solve for k here, if you multiplied x over, that means that this equation right here is also correct. That and it makes sense that if you multiply and divide by something, that'll give you that original something. And then the notation for how we say inverse variation is right here. You say y varies inversely with x. Inverse variation notation. Now, when you are doing inverse variation, we're gonna look at two different ways here to do these. So you can either use a table or you can use an equation, and what we'll do is I'll show you both for these. So what we have here in this example, we're saying suppose y is inversely proportional to x, and that y equals 12 when x equals 10. So let's see, 10 and 12, and what we want to know is find y when x is 40. So we don't know what y is here. Now, there's a couple of options here that we can do. So the first thing that we could do, so I'm impartial to making a k column here, and with inverse variation, the k column, remember, k is equal to y times x. So we're going to say, okay, well, 10 times 12 is going to give me 120. And then from there, all you have to say is, okay, well, 40 times what is going to give me 120. It's the same type of thing here. So whenever you figure out the value of k, if you want to use this equation up here, you could say we want to find y. So what is y when k is 120 here? Excuse me. And we substitute in x for 40. And it's quite literally basically the same thing. It's just a matter of preference on whether you'd rather work with an equation or you'd rather work with a table. And so we're going to look at another one here real quickly. So we're going to use the same table. We're going to say 10, x, y, and 12. And we want to know what x is when y is 19. I don't know why I wrote a y. So again, we want to know, so we've got this k column here again. X times 19 equals 120. We want to know what number would do that. And to figure that out, we would say, okay, well, that means that 120 divided by 19 is going to be our value of x here. It's not going to be as perfect as it was before. So give or take, x is going to be 6.32. So with inverse variation, what we're seeing here is we've got things that are being multiplied by something, and when those things multiply out, they should give you this constant k, this inverse proportion, and we can use that to make predictions or to make a model for this inverse variation in other spots once we recognize this pattern. So we're going to look at a couple of more examples here. So on this example right here, we've got this triangle, we've got this angle theta here, and we've got this angle phi here. And these are the two smaller angles of a right triangle. So we don't know what the measure of these are, but we want to say, okay, are these things inversely proportional? Yay or nay? Yay or nay? And we want to figure out as one increases, if we multiply one, will the other one decrease by the same amount? So let's see, I'm trying to think, what would be a good angle measure to use here? We're going to set theta to 20 because we need to try and figure out if this is true. We need to figure out a test case. So if theta here is 20, since this is a right triangle, that means that phi here is going to be 70. So let's see here. Let's say we double this one right here. We're gonna take theta right here, and we're gonna double this. So if theta doubles, so we'll just say 2 theta is gonna be 40. So if we double that angle right there, and that's 40. So if these are inversely proportional, when we double this, the other angle phi here should get halved. Now, half of phi here is going to be 35. Now, if you're looking at these two angles now, if I doubled this one and halved this one, we should still have the angle measurements for a triangle. Now, you need to think to yourself, could I make a triangle with 40, 35, and 90? And hopefully you're saying the answer to that is no. So we cannot make a triangle here when we double one and half the other. So that right there is a counter example for them being inversely proportional. Cannot have phi and double theta and it not work. And so this also goes to show that it's very, very easy to prove something wrong. It's a lot harder to prove something right. So then the other thing that we want to answer here is we want to know, so our tangent of theta and our tangent of phi inversely proportional. So we're going to bring back some geometry here. So real quick, what I'm going to do is I'm just going to label these sides. We can use side 1 and side 2. Now, as a reminder to you all, the tangent is equal to the opposite over the adjacent side. It's TOA, like SOHCAHTOA. And so with this, if we do tangent of theta here, so if theta is the angle that we're talking about, let me find, then the opposite side is across from it. So that's going to be tangent of theta is 2, angle 2 over angle 1, or side 1. Let me put S2 and S1. I apologize. I'm going to have so many people confused here in a second. I apologize about that. So then when we do the tangent of phi here, so we're talking about this angle right here. So the opposite here is side 1 over side 2. And so what we're trying to ask ourselves are these two things inversely related? And so in short, or or take a second and think to yourself, are these things inversely related? Looking at tangent of theta and tangent of phi. Looking at what those end up being, and come to a conclusion yourself real quick. So yes, they are, because they have those, this one's multiplying side 2, this one's dividing side 2, this one's side 1, this one's multiplying. It's dividing, multiplying. They're doing the opposite things there. And so this is inverse variation. So we're going to look at one more example, and then we're going to move on to looking at some of these powers, and then we will call it a day. So I'm looking at number 6. I actually pulled this from the problem set because there wasn't a ton of examples here. And so what we're looking at is, so if we got the time taken to landscape is inversely proportional to the number of gardeners. So if 5 gardeners could do this task in 6 hours, if we know it's inversely proportional, we want to know how long is it going to take for 3 gardeners to do this. And so, again, I am always impartial to making a table here just to kind of visualize what's going on. So we're going to do G and H here. So we got 5 gardeners, and that's going to take 6 hours. And we want to know for 3 gardeners, how long is it going to take for them to do this? Now, again, I always like making this little K column for this. I think it makes life a little bit easier. So K, as a reminder, is what you get from multiplying your 2 variables here. So in this case, our constant of proportionality here is 30. And so now we need to ask ourselves, well, 3 times what is going to give us 30? And in your head, you should probably be saying, oh, well, that's actually probably just going to be 10, Mr. Price. And again, if you would rather use the equation for inverse variation to do that, just turn this into H is equal to K over G. And so then H here would be 30 divided by 3, which would be 10 hours. So that's some pretty basic inverse variation. So what we're going to do, kind of similar to what we did last class, is we're going to look at now what it looks like when we're dealing with exponents, when we're dealing with powers here, and then we can go from there. Now, I unfortunately don't think that I gave myself an incredible amount of room here, so we will just have to deal with that when we get to this bridge. So we're going to be looking at example 6 on page 172. So if you want to look at that, you're welcome to. And again, I am always impartial to making a table here. Mr. Price is a big table guy, if you can't tell. So what this says is, suppose that P is inversely proportional to the square root of n. So let's see here. So the way we'd write that out is that P is inversely proportional to the square of n. So over 1 divided by n squared. So we're going to say, okay, when P is 40, n is 6, and we want to know what is P when n is 12. So we can see pretty quickly here, we can see pretty quickly here that n is being doubled here. So n is getting multiplied by 2. I'm going to give myself a cutoff there. So n is being multiplied by 2. And so what that means here is that n squared is being multiplied by 4. Because we got to remember that P varies inversely with the 1 over n squared, the square of n. So then what we're going to say is, okay, well, 1 over n squared is being multiplied by 1/4. And so this is what we're going to multiply P by. This is going to be what we end up multiplying P by. So we'll say, okay, well, P here, from here to here we multiplied by 2. From here to here, we're going to have to multiply by 1/4. So we're going to say, okay, well, what is 40 times 1/4? Well, that is going to be the value of 10. So where this doubled, instead of this decreasing by 1/2, it's going to decrease by 1/2 squared. If that makes a little bit more sense. These power ones are just a little bit tricky. And so we'll look at another example here. So same condition initially. So we're still going to use the same table. We're going to say 6 and 40. And we want to know what is n when P is 90. The old P90. That's an old school Call of Duty reference for those y'all who play the CODs. I haven't played COD in a hot second. So sorry about that. So what we need to recognize here is what this is. So this is increasing. So this is getting multiplied by something. So to get from 40 to 90, you have to divide 40 by 40 and then multiply it by 90. Or multiply it by 90, divide it by 40, whatever you want to think of that as. And so what's happening here is P gets multiplied by 90 over 40. We're going to reduce that, though, to 9/4. So then what that means is that 1 over n squared got multiplied by 9 over 4. Which means, so n squared, the flip of that, the inverse, means that n squared got multiplied by the flip, which is 4/9. So then if n squared got multiplied by 4/9, we need to figure out what n got multiplied by. So the square root of 4/9 right there is going to end up being 2/3. So then to finish this out, all that we've got to do is say, okay, well, anytime this increases by 9/4, this is going to increase by the flip of that and then take the square root, which is 2/3. So we're going to say, okay, well, 6 times 2/3, and that should equal 4. Nice little logic puzzle there for us. I like it, though. I like it, though. So we're going to look at one more, and then we're going to call it a day. So we're going to do number 3 here on page 173. So what I want you to do real quick is I want you to pause this, and I want you to see if you can, if you can do this one yourself. So pause it here. Let's see what we can do, and we will go from there. So then I'm going to go ahead and start solving this problem here. So it says that suppose m is inversely proportional to the cube of c. So we're going to say m is inversely proportional to the cube of c. And we want to know, okay, when c is 12, can you find m? So c and m, okay. So then what we want to try to do is we want to try to find m, so question mark, when c is 8. So we see that c decreased here. We see that c decreased here. And so what we've got to try to do is say, okay, well, C got multiplied. So what could we multiply 12 by to get it down to 8? We need to figure that out real quick. So C is multiplied by, what would that be, 2/3? Yeah, so 2/3 of 12 is 8. So if C gets multiplied by 2/3 here, then that means that C cubed is multiplied by the cube of this. So that's going to be 8 over 27. And I'm going to grab my calculator real quick because this is going to very soon turn into math that I'm going to need to be able to do. So then from there, we're going to say, okay, well, so C cubed is multiplied by 827. Well, that means that 1 over C cubed, the inverse of that, is multiplied by 27 divided by 8, which means that that is what M is going to be multiplied by here, by 27 over 8. So to figure out this answer, we're going to say 64 times 27 over 8. So that's going to be 8 times 27, which is 216 for M there. That was a bad circle. I apologize. And then the last thing for today, we're going to find find C, excuse me. So same problem. So we've got C, we've got M, 12, 64. And we want to find C when M is 1. So we have to say, okay, well, what is 64 getting multiplied or divided by here to get to 1? And to that, you should say, it's getting divided by itself, which is the same thing as multiplying it by 1 out of 64 there. And so what we're going to say now is that M is multiplied by 1/3 here. Or by 1/64. I don't know where I got 1/3 from. So then what that means is that 1 over C cubed is multiplied by 64, or by 1 over 64, excuse me. So then that means that C cubed is multiplied by 64. So then that means that C, so when M gets multiplied by 1 over 64, that means C is multiplied by the cube root of 64, which is 4. So then to figure out C, we're just going to say, okay, well, 12 times 4 is 48. And we're good to go. So those are our notes for inverse variation. If you all have any questions at all, please let me know and we can figure out some stuff to do for that. Shoot me an email or talk to me through Zoom and we will get you all squared away. But you all have a good rest of your day and I will see you later. Bye.